Good morning, guys. I am doing the videos again after getting some technical help from my video expert. So I wanted just to go over again the unit rate notes. Some of the classes have gotten further than others, so you can fast forward till you have blanks in your notes. And also know that I posted this sample in the folder, the class folder for chapter 5. I created a new folder for the new chapter. Just an FYI for tomorrow. I've looked over the problems that are assigned today, and you should be able to, from the textbook lesson 4.3, solve the problems today for the extra practice 4.3. I've posted the solutions from the textbook, which is more than just the answer key. It actually gives you some of the steps. And you still have the solutions from the lesson 4.3. So my suggestion, if you're stuck, is to look at the problem and see if you can find a similar problem from the ones we went over on Friday. So for example, is it a before-after problem, or is it a part-whole problem? Is it a problem where there are 3 ratios already together, like compared to each other? Or is it 2 separate ratios that you have to make the middle term equal so that you can compare? And see if you can find a problem that's like that from the solutions on Friday, and then use that information to help you solve the ones from today. I know that I have your homework to correct, but my solutions are still posted on portals. Okay, so let's start at the top here. Just a reminder again of what the definition of a ratio is. A ratio is a comparison of 2 quantities that have the same units. So we, in chapter 4, we're only talking or comparing things that we're measuring the same quantity, or the same, for example, we were measuring length, or we were measuring weight or mass, or comparing things that are the same, versus a rate, which is a special kind of ratio that allows you to compare different units. The most common rate that you'll have experience with is the speed, miles per hour. Now, if you remember, with the ratio, remember the anaconda and inchworm situation, where when we were measuring the same thing, we had to make sure that the measurements were in the same units. So we had 3 centimeters to 4 meters, and if we just wrote the ratio 3 to 4, it distorted the comparison and made it look like either the inchworm was really, really, really big, or the anaconda was very, very, very small. And we had to change the 400 meters to centimeters in order to get a correct comparison. So now we have the ability to compare things with different units and with a rate. And we most often deal with a special kind of rate called a unit rate. So if you look here, here's the definition of a unit rate. Unit rates are ratios with a denominator of 1. And it allows us to compare how much per 1 unit. And the way that we solve it is that we compare how many units of quantity 1 for each of quantity 2. And how does it work? Well, it's pretty much division. This is where the ratios and rates being written as a fraction help us, because we just use our fraction math rules. But in order to write the unit rate, we first have to figure out which quantity is divided by which. So first we write the rate as blank per blank. And we're going to use this shampoo problem as an example here. So for example, this bottle, the cost of the bottle is $5.19. And we compare that, or rate that, over the total amount in the bottle, which is 32 ounces. Then we divide the first number, $5.19, by the second, and that gives us 16 cents. So we would say this as 16 cents per ounce. And then we need to check and make sure the answer is reasonable. All right, so a couple of things to remember. When we are writing rates and unit rates, the units have to be in the answers. Blank per blank. It's super duper important because the numbers don't mean anything without the unit. And one hint is that money always goes on top in the numerator. So we'll always have dollars per pound, dollars per box, dollars per ounce. Okay, so let's come over here to the right, and we're going to do this try it problem. And like I said, the rate that you're probably most familiar with is miles per hour. But in this case, we're doing a problem where Carl drove 40 miles in 50 minutes. And Teresa drove 35 miles in 42 minutes. Who had a higher average speed? So in order to do this, we take Carl's information and we write the rate of 40 miles per 50 minutes. Now, of course, this is a rate that we're familiar with, so that's why we know that the miles goes on top and the minutes goes on the bottom. And I just told you that money always goes on top to the bottom. So depending on your experience, you would have a sense for most of these, how the rates work. But of course, that's an issue that if it's something that you're not familiar with, then you need to ask. Like if you've never ever been to a grocery store and seen the little tag where it tells you the miles per or the cost per ounce, then you might have a question about that. That's a legitimate question to ask. But I'm pretty sure you've all gone to the grocery store with your parents at some point. So in any case, we write the ratio 40 to 50. This is not a unit ratio. A unit rate. This is just the rate. Then we have to convert it to a unit rate. And what I want you to see here is that we first reduce the fraction to 4/5, just because it's a little simpler to deal with. And this is really not any different than writing an equivalent fraction with a denominator of 1. So if we were looking at this as a fraction with a denominator of 1, to get to a denominator of 1, we have to divide the denominator by 5. And then we have to do the same thing to the numerator in order to keep it equivalent. So when we divide 4 by 5, we get 8/10. And so really, we can rewrite this rate as a unit rate of 8/10 of a mile for every 1 minute. Now, because it's a 1, and any number divided by 1 is itself, we normally don't write this. You would just see the rate written as 8/10 of a mile per minute. But this is really what's happening in the math. So if it helps you to write it this way, in order to think about the numerator, denominator, the miles per minute, that's totally fine. But eventually, you'll see that you won't see that anymore. So now let's do this for Teresa. So Teresa, we take her information. She went 35 miles in 42 minutes. And if we divide, we get 83 hundredths of a mile per minute. And here they wanted us to write it on a speedometer. Now here's the interesting thing. Speedometers, if you look, the unit is miles per hour. And what we calculated was miles per minute. And so it would make sense that we would multiply by 60, because there's 60 minutes in an hour, to get an hourly rate of 49.8 miles per hour. So I want to show you how this works with the units in class on Tuesday, if someone will remind me, because that's such an important skill, especially as you start to apply the mathematics to science. There are tons of engineering classes that I was in that knowing the units helped you sort through all the formulas in order to solve problems. So I want to show you how to do that in class on Tuesday. Okay, so obviously if you compare, Teresa wins. She was the faster driver. Okay, so then let's move over here because I want to do this other example. And this is that a box of 100 hexagonal floor tiles covers 16 square feet of floor. How much area does a single tile cover? We want to know how many square feet there are per tile. So again, to set up, the first quantity, the quantity in the first blank belongs to the numerator, 16, that comes from the problem. And the second quantity in the second blank is the denominator, which we have out of 100. And when you divide that, you get 16 cents per foot, 16 feet squared per tile. not money. Sorry about that. 16 feet squared per tile. And then another kind of problem that you'll see is the rate when it comes to work. So here we have a crew that paves 850 feet of road in an 8-hour day. Find the unit rate. So what we want here is the number of feet per hour that the crew can put down. So feet per hour, we were told that it's 850 per 8 hours. So that's about 106 and 25 hundredths of a foot per hour. So now if I wanted to calculate how many hours it would take, or how many they could do in 10 hours or 16 hours, now I have a rate that I can use to solve problems. And that's what we're going to talk about in lesson 5.2. Okay, so the last problems that are here, we did the first shampoo bottle problem. We were comparing which one was a better value. That means the lowest cost per ounce. So there were two more. Here's one. And in this case, it was $3.95 in 20 ounces. So we divide $3.95 by 20 and we get 20 cents per ounce. And in this one, it was $4.69 for 27 and 5/10 ounce bottle. And we calculate that to be 17 cents per ounce. So which one's the better deal? 16 cents, 20 cents, or 17 cents? Obviously, it's going to be the 16 cents per bottle. Per ounce. So one last reminder is that when you think about unit rates, first think blank per blank. Then write the first term in the top or the numerator and the second in the bottom denominator, and then you divide. And don't forget to add your units. All right, so finish these notes, and I will we'll work some practice problems tomorrow, and we'll move on. Have a good day.